Right. Hi all. So welcome to Multimodal Weekly. This is a virtual webinar series hosted by the team at 12 Labs, an initiative that we've been running over the past 3 years or so. We're meeting on a weekly basis to discuss a variety of different topics, mostly focusing on the interest about technology and our research. So oftentimes it's going to be researchers coming in and talk about various papers in multimodal AI and foundation models. Recently, we've been having more customers and partners sharing how they build application with our technology in different verticals. And finally, we have developers, community members sharing some of the latest projects that they build with our video understanding technology. These are some sample content from the past month or so. You can see we have a wide variety of application, everything ranging from education to advertising, to sports, to coding, security, etc. So for today's session, super excited to have two exciting projects being built with 12 Labs API from actually two recent hackathon that we got a chance to be sponsored. So the first one is from Hack NC State, which is a hackathon hosted at North Carolina State back in February. So this group from Michelle Varghese, Shreyas Raviprasad, and Shreyad Devaraj, they will present their project called HireLens, which detects AI-assisted responses during technical interviews using multimodal analysis, both in real time and through uploaded recordings. So that will be the first presentation. And then second half of the webinar, we'll have Lukhsaan Elankumaran, Andrew Peng, and Attila Atumbaira present their project called TrendID, which transform viral internet moments into premium status symbols. It essentially generates rebrands goods into different assets, capturing high margin demands before the mainstream catch up. So this was being built during UFT hacks at University of Toronto back in January. So yeah, you can see that there's two interesting use cases. One more on education, the other one is more on advertising. So very excited to see how they build 12 Labs and share best practices during the session. And yeah, we have a pretty small group today, so feel free to, for attendees, feel free to send question on a Zoom chat or unmute and ask question in real time. So with that, I will stop sharing my screen. And yeah, I will let the first group get started. So Michelle, you want to unmute and get started?
Yes. Hi. Thank you so much, James and 12 Labs, for giving us this opportunity to present our work. I'm Michelle, and along with my teammates, Shreyas Devaraj and Shreyas Raviprasad, we're excited to present HireLens, a system designed to detect AI assistance in interviews. So with the rise of tools like ChatGPT, interviews are changing, and not always in a fair way. So HireLens aims to bring trust back into the hiring process. The next slide. So the problem, candidates can now use AI on a second screen during live interviews, completely invisible. This leads to perfect scripted answers, and interviewers have no reliable way to tell if it's genuine. As a result, companies risk hiring candidates who may not actually have the skills that they claim to demonstrate. Next slide. So here are a few statistics. You can see that 35% candidates actually who show active signs of AI cheating in late 2025 is 35%, which is up from 15% since the early of last year. And so the data makes the urgency clear. AI assistance in interviews has more than doubled in just over a year. Dedicated, invisible tools are now involved in nearly half of AI-assisted cheating cases, and significant share of candidates openly admit to it. So this is no longer like an edge case, it's a systematic problem. So what is our solution? HireLens, a multimodal AI interview verification system that detects AI assistants in real time. It works across 4 layers: gaze and eye movement tracking, speech pattern analysis, AI generated content identification, and finally, a forensic evidence report that gives recruiters clear, actionable insights to act on. Next slide. So let's go into the details. So here are some behavioral signals that we look for, that our system looks for. So one is visually. We track gaze and micro glances towards a second screen. Linguistically, we flag suspicious perfect grammar and like zero filler words. Temporally, we detect unnatural pacing and response delays. And on content, we identify overly structured generic answers that lack a personal touch. So no single signal is conclusive, but together we can build a strong case.
Yeah, thank you, Michelle. So going over the technical core of how HireLens works. As Michelle mentioned, HireLens is a system that's designed to detect AI-assisted interviews on a multimodal scale. So this, based on the cues that we saw on the previous slide, that includes video, audio, text. So for the core of HireLens, we had these three technologies help us build out the best effective system, starting with 12 Labs. 12 Labs is our main video analysis source that helps us detect eye gaze, body language, phone usages, things that you would see in a behavioral cue that would give you a flag of AI-assisted cheating. 11 Labs, it converts our AI-generated questions to natural, human-like audio. 11 Labs becomes our interviewer. Along with 11 Labs, we have Gemini Pro as the agent running on 11 Labs. So for every response that the user gives back, it is being detected as if it's AI detected, if there's AI in that response. So that together puts the system as a cohesive way to detect how the responses are treated. For that, we can see how each part of the pipeline builds to the end-to-end system in our system architecture. So starting with the question generation, when you get onto our platform, there is an AI-assisted AI interviewer that is by Gemini Pro, where we have adaptive questions based on job role and candidate profile. Voice delivery, as I said, is through 11 Labs. So you have natural language audio, and every response that the candidate gives back, it's then taken through Gemini Pro to as a tool call. The agent then analyzes the response for any AI-assisted content, which is now also called a shadow analysis, where we embed similarity between the candidate's response and what an AI-assisted response would be. So all of that adds in to give us the evidence report. After your interview, we have the video intelligence coming in, where 12 Labs, we use two APIs. One is the Analyze API, where the video is indexed and segmented to find out behavioral cues that show you the AI-assisted cheating. And then we have also the Summarize API endpoint as well. So in that sense, you'll know exactly the timestamps in your AI interview, where the assisted was detected, and all of this come into the evidence report, and this is timestamped with segments flagged, confidence scores, and all of these can be actionable by the recruiter.
Yeah, thank you, James. So now that we know the kind of blocks and the technical inputs that we have to detect malpractices, let's just go over how we're connecting all of these components together and how the outputs are flowing together. So the initial phase is basically the live interview part. So we have the live interview that happens where we gather different types of signals. These are your gaze detection, your facial presence, speech, and response latency. So we basically have media pipe here, which is doing all the visual cues for us. This comes down to gaze detection. It predicts how the angle of your face, where you're looking, and we have a bunch of rules that we have set up to sort of flag these suspicious behaviors. 11 Labs, as Shreyas mentioned, is a voice agent. So it's basically helping us to automate the interview process where we have an agent talk to you and the candidate responds back, and we have much more intelligent to and fro discussions. So these two are detected by the two components I mentioned before. And finally, we have 12 Labs, which is the place where all the magic happens. So it takes in the entire video. We have a bunch of prompts asking it to segment the video, flag suspicious behavior, and also explain why it decides that that behavior is suspicious. Because at the end of the day, we don't want something to be a black box. We also want the interviewers to understand why it flagged some behavior as suspicious. So that's where the insight engine comes into play. So we have it combine different inputs and modalities from behavioral, semantic, and visual signals. And it generates this report where you can find out which parts of the interview were suspicious, what parts did the candidate well, and where you think you should rather focus your attention on. So we also have another flow, which is basically a recorded video. So let's say that you weren't able to use this during a live video platform. You can also record a video of the interview and upload it here as well. And in this case, we have a different flow, which is basically Gemini Pro, which does the speech analysis, content analysis, and behavior. So it does extract the audio, get the transcript, and then passes it through an AI detector and kind of flags it between is it deceptive, suspicious, or clean. And you have 12 Labs again sitting in the back doing all the heavy lifting with the multimodal scoring, cross-model evaluation, and anomaly detection. So I'm just going to go ahead and show you how it works in action. And I'll just focus your attention to the right side where you get all the live tracking information. So you have the interviewer talking and you get all the detection on the right side over here. And MediaPipe gives you your angle of detection in live over here in the bottom. So let me just forward it. Right. So basically, once we have a bunch of rules set up where if you look here, distracted 6 times in the last 30 seconds. So these are rules that we've set up with MediaPipe, where you kind of understand if the candidate is looking away for too long, and if so, we kind of flag it in real time over here. And so we count the number of flags that we set up over here, and also the suspicion score, which is also being calculated in real time. So right now you can see there's a 26%, but eventually in the video, you'll see that I'm going to take out my phone and look at it for a bunch of seconds and then keep it back on. So this is suspicious behavior that you're seeing over here. And once I put down the phone, you're going to see that the suspicion score jumps up really high. So that happens about here in real time. And then you kind of see a critical flag that's being set over here. And this is telling you that the response itself was AI generated because of the visual cues that we got, and also a bunch of other MediaPipe flags over here. So let's say that your your interview is done. And while we send this to 12 Labs to do the indexing, all the multimodal magic that's happening in the background, we also give you the transcript of the interview. And this is done with 11 Labs, where you can see basically a transcript between the interviewer and the subject. And this is giving you an idea of what happened in the interview, where the candidate was doing something suspicious. And we also have flags over here. So this is the main report that we generate at the end of the interview. And you can see here that there's an 82% score, saying that it's highly likely that the candidate used AI to cheat. And we also give you an idea of what's happening in the background. So these are the 3 modalities that we mentioned before. So we have behavioral analysis, content analysis, and video analysis. And each of these are being done with different components. MediaPipe does the behavior, Gemini Pro and 11 Labs does the content speech, and 12 Labs does the video analysis and multimodal analysis. So you get a combined score of all of the three, and then you get your 82 score at the end. So if you scroll down, you can also see the detection flags that we had from MediaPipe, all that we saw in real time. We also record them over here, flag them into behavioral flags, and also the severity. So you see a critical flag over here, and that's probably because I used an AI-generated answer. So it wasn't related to the behavior, but rather just content itself. And the neat thing that 12 Labs does for us is provide timestamps on when certain malpractices were done. So you can go back to these, just play it around, and you can kind of see that where I had the phone in my hand during the interview. So this is like really neat and handy for interviewers to sort of figure out and jump to where they should be focusing on, especially where malpractices were done. And we have the full transcript again, like I showed before. So in case you want to go back to it and refer to it again. So this is all neat and good, but then how do you share this with another interviewer? So we have an export PDF option over here. So this allows you to export the PDF and report and kind of share it to others as well. So you can see how the report is generated here. Pretty standard stuff. It's the same content that we just saw earlier, just in a PDF format. So it's a bit more formatted and easy for you to share it with other interviewers as well. And yeah, you have the transcript in the back, just in case you want to refer back to the interview. So yeah, I think Shreyas is going to go ahead and explain the upload part of the video as well. So I'll let him take over from here.
Yeah. So this is the same flow, but for uploading the video, which is not during a live interview. Right now, I uploaded a video of an AI-assisted interview of a friend that sat in our platform. So I'm uploading this video. This goes through two behavioral analysis. One is the speech and one is the video. We don't have the media pipe here because it is a recorded video. And this was a video of the candidate using the phone, using content that is like pretty scripted. So you can see the way we flag it in the end is of, could you pause the video 1 second? Yeah, so it has like 30% for the video analysis and 70% for the content. So all of those together ends up in the final score or the final report that you see here. Everything else is similar to how the live video works. The same flow that Shreyas mentioned earlier. You see the full transcript and you also see, based on the response, you see how much, like what is our estimate of AI detection in the response. And when you click on it, you also see the reason why we could have possibly flagged it as an AI detection there. We also have the video segments of where it was flagged and the same export PDF option that you saw in the live mode as well. And then this is another example of a real interview where the friend of ours actually spoke in a normal interview, how he would generally do it. And we see that the content had 0 flags, whereas video, it also has no flags, but it gives you like positive output there, saying they did not use anything. It was eye gaze, was no visible phone, all good cues that you would normally see in a well-structured interview. So yeah, you see the transcript in the same export PDF option. Yeah, that's pretty much about our demo and what we built with HireLens. Coming to the future roadmap, we thought about platform integration that is included in video interaction portals like Zoom, Google Meet. This would be another agent sitting in the Meet that would possibly do the same analysis and give the interviewers a real-time detection of what is happening. And then we also thought of building an intelligence engine, which is basically all the cheating pattern a library of all of these patterns. That would help us improve our accuracy and reduce false positives, which also includes cross-candidate behavioral benchmarking. So there is more information across candidates that would help us improve our accuracy. And finally, contextual AI. So right now, all the interview from Level Labs that you saw, it does not adapt in real time based on like the responses that you give. But since all of these are agents that are like meant to grow with context, this would help the interviewers a lot to further the questions based on the responses that the candidates give. So this would help us detect anomalies across groups of candidates and not just a single individual. So the goal is to move from a detection to a fully adaptive, intelligent interview system. And that's about HireLens from us. Thank you. So I also see one question, which is how do you deal with sophisticated users that use scripts to reduce AI fingerprints in their responses? Which is why we went ahead with the multimodal approach. So if the content itself cannot be flagged, the behavior can be flagged. The way in which they speak, the gaps in between, so it might not just be like the speech. You could ask ChatGPT to give you a very natural response, and that would not seem AI generated. But when you do that, you know what you're speaking, and you probably don't take enough gaps in between. You don't think. It's pretty straightforward. So all of these are like the cues that we built together, and which is why we have this multimodal approach. And in the end, the report has all of these signals that have a weighted percentage in order to give you like a response. And the rate of false positives, we did start with a lot of false positives, and hence we did do a lot of prompt engineering and work with agentic tool calls to like have a more structured way of detecting these segments and like flagging them as detection. And also, which is why we have it weighted, and you saw a percentage of 85% AI detected. So we have a threshold. So all of these added and improved the way we like detect our false positive rate and helped us reduce it a lot. So in a way, it genuinely just dependent on how well we worked with our model. And I think Shreyas also worked with prompt engineering.
Yeah. Just to add on to what Shreyas mentioned, so I think we do see a bunch of false positives, but I think the main concern was to reduce the number of false negatives. And so what I mean by that is, if in an interview the candidate is indulging in certain malpractices, we want to make sure that we always flag these kind of practices. And in the case where something looks suspicious but it actually isn't, I think it's a little less dangerous to flag it because we always are going to have a human at the end sort of evaluate the report and talk to each other and sort of come to an agreement on that.
Awesome. I think those are the only two questions I saw in the chat. So yeah, if there's another question from the attendees, feel free to put that in, and then the team can answer. Maybe one question from my end is, you have two pipeline, one for live video recorded on the webcam, and the other one is kind of the batch, you upload a video, right? And then the upload mode, the upload mode where people can submit recorded interview. Is there any like meaningful differences in terms of performance or in up to our last model between these two pipelines?
So it does. So the both Gemini and the 12 Labs, it hits the same endpoint with the same prompts. So in essence, the pipeline is going through the same path. Performance-wise and uploading, it needed I think I would say a little more time because we had to like save the video locally and then curl it, upload it in segments because of the size of the interview. So it took a longer time to index it and then work on it. But I would say like the live mode had more features to it because of media pipe and also like each content being flagged real time. So that was useful there. But performance wise, there is actually no difference. The live mode just had more cues to work on.
Awesome. Okay, I think I just saw like two more questions if you want to answer it. Michelle and Shreya, you guys want to answer the two questions? Three questions actually.
Yeah, so I can take on the question on why we use multiple LLM models. So I think it was mainly just to understand the comparison between which ones perform better. Because we kind of saw that like there was no one model fits all or like one solution fits all. And it kind of came down to how we were able to extract the strengths of each model. And just to give an example, so like MediaPipe does really well in understanding visual cues, and 11 Labs does a good job in transcripting and especially the voice agent part of it. And 12 Labs was the best choice for us to sort of figure out, especially the Pegasus model, in explaining and analyzing the multimodal interview as a whole. So the thing that I liked about 12 Labs, especially their analyze and explain features, was that it wasn't just detecting or giving us like a 0 or 1 label output, but rather like a explanation. So you can kind of think of it as like as a chain of thought reasoning for LLMs and how they, or rather we force them to give us an explanation or reason for why they think a certain thing, a label is existing. So we kind of experimented with all these things initially. We started off with an initial model, and because it wasn't able to work as well, we kind of branched out and expanded into this pipeline that you see today.
Yeah, and to add on to that, it's LLM wise, Pegasus is one model that's behind N12 Labs, and it's Gemini that's going. So 11 Labs is just it's technology that uses Gemini in essence. So that would be our two LLM choices. And did you guys wipe code this solution? It was a 24-hour hackathon. It was a bit of both. We started off, had a little bit of wipe coding as well, because especially our front end, because yeah, we had to get all of this in within the specified time frame. So yeah, it was a bit of both, I would say. And then
There's another question on like how does it deal with interviewers using personal notes during an interview?
right. Yeah. Does this mean the candidates using personal notes? So this would definitely account for a false positive because I mean the prompt did handle this to an extent, but um, the media pipe would say you're looking away from like away from the screen or something of that sort. So which is why even in the media pipe we have this idea of like it's not just looking away once or looking away for a short amount of time. So we have those embedded in as well, where like you could look away for multiple times, and that's when it starts flagging it. And of course, as Shreyas said, there will be a human in the loop in the end because these are just like insights to the interviewer, which they would have missed while taking the interview. So this, along with the timestamped, the interviewer would see it and like not flag it as an AI assisted response there.
Awesome. Yeah, I think those are all the questions that we have for the HireLens team. I really appreciate you walking over the details. Very nice design slide, by the way, to explain your solution. And I think some of the like future enhancement on Zoom agents on Zoom meetings and browser based, those kind of things also are pretty cool. And I know that there's these are like real integration, right? That people can put on for like this application. So yeah, I excited to see how you can continue working on this project and make it even better. All right, thanks, guy. So with that, let's pass the mic to the second group, TrendID. If you guys want to share your screen and go ahead and get started.
Yeah, sounds good. I'll share my screen.
Okay, are we good to go? Imagine knowing exactly what your customers want to buy next without ever meeting them, surveying them, or waiting for them to tell you. For Shopify merchants and growth teams, the ultimate pain point is time. You spend weeks, sometimes months, designing and launching a product, only to realize you missed the cultural nuance of your target group, and now you're left with dead inventory and missed momentum. And this is a real issue, as identified by some top Shopify executives, as we can see in the article right there. So TrendID solves this. We map fast-moving social identity signals into practical, high-margin product changes automatically. So to give you an idea, imagine tweaking a t-shirt's design and copy just hours after two 30-second viral YouTube shorts establish a new visual icon or motif or something. So first, let's take a look at our pipeline for generating suggestions for how to change your Shopify page. So we have 5 key steps. Step 1 is the metadata and search. So we start with 7 metadata tags, such as aesthetic tags, temporal cues, and then audience anchor terms. And then these seed our initial YouTube queries. Step 2 is video selection. So from these results, we don't just pick the most viewed, because the most viewed could be some skewed, just coincidentally popular video. So we pick the 2 videos that maximize the viewer per hour rate across our tags. So it's not just the raw number, it's viewers per hour. So this guarantees that we're capturing high momentum short form content. And now step 3 is our multimodal analysis.
Yeah.
Wait, sorry, are you saying something?
Yeah, just one note. Are you supposed to switch your slide? Because I think it's still at the article slide.
No, we're just sharing the video. We don't unfortunately have slides open.
Yeah, we're using a video as our slide deck.
All right. Yeah, continue.
Yeah, we'll change it. It's just this part's just introductory, so we're staying on this part.
Right.
Yeah, so the multimodal analysis, so this is where the 12 labs come in. We send our clips to 12 labs, and then 12 labs gives us scene descriptions, action annotations, and audio cues, and also just high-level semantic labels that we can use later. Fourth, we merge this with Shopify data. So we take the trends JSON output and then combine it with the store catalog JSON, and this creates together a semantic planning table of product level suggestions. And then finally, we push these changes to the Shopify admin, and then we run it. So now Attila will go more in detail about the pipeline.
So our pipeline starts with, by the way, can you all hear me? Is that okay?
Yes, we can hear you.
Okay. So our pipeline starts with scraping the initial tags we need to work with to pull the YouTube videos and then analyze with Flow Labs. So the way we do that is we use the Perplexity API, which allows us to scrape the web with LLMs and semantics every 5 or 10 minutes, or like it can be adjusted how frequent you want it to be. And then we gather those high momentum tags, we scrape with LLM intelligence, and then we feed them into the YouTube search algorithm. That's the perfect step.
Okay, so now I'll talk more about how we use 12 Labs in this. So we use 12 Labs because of its multimodal capabilities. We fuse the visual scene parsing, audio transcription, and also generative summarization to get our actual insights. So first of all, we need to model this. So what we used was the Pegasus 1.2 model to create our index. So we picked Pegasus because it's highly generative. It synthesizes the insights across both visual and audio evidence. But obviously, if this fails, we fall back to a Marengo model index, which this is more of a standard index. It more just looks at the metadata instead of the actual content inside of the video. So this two-tier strategy keeps our uptime and coverage extremely high, and it's also highly reliable. So now, after we have our index registered with modalities such as visual and audio, we index the video. So this uploads the file to the indexes via a task endpoint. And because we're dealing with APIs, we pull the endpoint until processing is complete. And then if it fails, we also have retry and backup logic to just handle any issues in transit that may occur. And now the key part is the text generation. So we call the 12 Labs generate endpoint with streaming turned off to avoid potential JSON parsing issues. But if the API ignores this flag, we also have a fallback to stream parsing. And this handles the incremental chunks. It also recovers from truncated JSON and enforces timeouts. So internally, for example, we would prompt the system with commands such as for each scene, list physical props, color palette, and a one-line product tweak that would resonate with viewers. So our script then cleans up the output to normalize things such as stray quotes, empty tokens, and then we also convert into our view velocity map. So what we get back is our semantic output of timestamps of scene actions, audio cues, and also visual motifs that we mentioned earlier, and all of these come with a confidence score. So finally, we synthesize these chunks into recommendations. So the reason why we use 12 Labs instead of just some generic computer vision, some more basic computer vision, is because here we, instead of just seeing objects, we understand the more spatial temporal geometry. So how things move and interact over time. The interactions is one of the key points here. So yeah, that's why we use Pegasus and Marengo, because instead of just looking at a chaotic video, we turn it into a database of human behavior. So now after we have these trends and recommendations, we upload to the MongoDB Atlas.
Yeah, so once we have these trends, the Pegasus and the 12 Labs and the Perplexity pipeline identify currently that's trending throughout social media and the internet, it is then uploaded to this MongoDB Atlas, which then has multiple Gemini agents for each business on our Shopify businesses that will take the current marketing for their products, where it could be like clothing or any products that they have in their website, and the Gemini agent for each business would be comparing their products' current marketing to the trend and seeing if there's an opportunity for us to utilize the trend to market the products on the Shopify store better. So here we have a Shopify embedded app that we created that would pull from the MongoDB once the Gemini agent has found any recommendations that it can utilize through the product marketing. So this is a Shopify website that we made just for this demo. So we would have once the Gemini agent, so earlier on in 12 Labs, we identified one of the trends as Aura, which is something that was trending recently. And on the Shopify store where we have various different products, one of the products that we have is a trench coat. So what the Gemini agent did was it found that there was a opportunity here for us utilize the Aura trend to better market the trench coat from its current marketing to better ones. And it was also show any other trend insights that the 12 Labs and Pegasus and Perplexity pipeline was able to find. Once we have this trend, the embedded app that we have would have the current description of the current product, as well as the new description that we created through Gemini's agent that we combined with the trend that 12 Labs found, and be able to show it to the business owner and or whoever's managing the website and be able to accept or reject the suggestion. And through Shopify's GraphQL API, we are able to automatically update the website in production once the user accepts it. And if they do happen to accept it here, as we can see, the website in production would then update the marketing and any other like tags and SEO capabilities in order to utilize that trend.
Yes, so to recap, TrendID shortens your time to market by converting social identity signals into concrete product updates. And to just address some potential concerns, you may be wondering, well, auto-updating a Shopify store sounds pretty risky, right? Because what if the AI suggests something off-brand or incorrect? Well, this isn't an issue for TrendID because TrendID is designed as a human-in-the-loop system, so we don't just blindly overwrite your database. We can push these suggestions into a staged state where the human actually previews it, and then if the human approves of it, we actually push it into the actual website. And then something else that you may be wondering is, how do we distinguish between, let's say, a massive macro trend and just a noisy 24-hour meme that will be dead in like 2 days? Well, that's why we don't just look at view counts, we look at viewers per hour. So yeah, and then we also look at corroboration in our semantic planner. So if we see something appears in only one video, it gets a relatively low score. But if some motif appears in multiple trending videos, then there's a high score and a much higher possibility that this is an actual real trend. And yeah, that is TrendID.
Right. Thanks for going over the demo and walk through the explanation of how it was being built. I guess we can use the remaining time for any Q&A question that people have for this project. Maybe I guess start at, so like you mentioned one of the challenges with this project is to automate these different changes, right, in the Shopify store owner. Can you talk more in details on those challenges and what exactly make it challenging?
So are you talking about the challenges in the like updating the store itself?
Yeah, the Shopify store owners admin page, right?
Yes, so originally we planned on having it update like the UI as well, like how the website looks, like new UI elements, like maybe even adding tags like brand new, like aura, like some sort of like better UI for the user. But due to like Shopify's like limited capabilities with the GraphQL API and what you're able to do, the most that we were able to do was be able to update like different text descriptions, metadata tags, as well as other like lower level capabilities that were able to like affect the SEO of the product. So maybe given more time we can use, because they had an old REST API that you could use, which would actually be able to update the core websites like files and etc. to be able to actually update the UI and make it look different based on the trends. But it's become deprecated, so we had to pivot to the GraphQL and aim for a more SEO approach.
Great. I think Misha just put a question, and then Wajid as well. If you guys want to take a look at the question and answer them.
Sorry, are you saying to address this question in chat? Let me see.
Yes.
So what we do is we have this. So we would have that website. So this would be per website. This is like a Shopify embedded app that users when they have a Shopify website, like their own business, would be able to download this app through the Shopify store. And this app would be able to analyze their products and their current production website and all the marketing for it. And then you would be able to suggest new products. You'll be able to adjust the current marketing for products, and then you'll be able to automatically change the way the website presents them via the text itself, the metadata, the SEO, and other like smaller features that the user will be able to review and accept based on what the Gemini agent is able to generate based on the connection between the current products marketing and the current trend that the Perplexity and 12 Labs pipeline was able to find. And the second question, I think that also answers that. It is able to suggest new products as well. you are able to suggest new ones. I think the crew neck was one of them that wasn't currently on the website. So that was one that we were able to suggest based on something we found, something that the Perplexity and 12 Labs pipeline found online of like chill guy clothing that seemed to be trending a lot more due to that meme that was going around.
Great. Did you address the question on atomic pages with SEO artifacts?
But what do you mean by like atomic pages?
I think we don't create completely new atomic pages. We instead are just creating sort of a draft page under the same URL that the merchant can view. So, so yeah, we're not creating new atomic pages for every single trend and every single update. We're just we're mutating the existing page.
Nice. Okay, that's a new question as well.
Yeah, so there are changes on the website. There is, it's not in this video, but there is a rollback feature that users are able to roll back to a previous version. And if there is any new trends, like users are able to, it would be automatically suggested as well. So once a trend goes out of hand, like the MongoDB, it would not be in the MongoDB anymore. So the pipeline would check these trends and see how if it's constantly updating. So it's like a cron job that runs like every once in a while that we would have a specified time limit. So whenever that happens, then we would find new trends that happen. And based on that, if there's new trends in store, or if there's old trends that have died out, it would suggest new ones and upload the MongoDB, which our front end would reiteratively call and see if there's new trends to be updated or not. Any reason why Gemini was a model choice? To be honest, most of us are just more well versed with Gemini. Andrew, do you want to talk about that? Like,
Yeah, well, I think in the architecture for Gemini, it's built to be relatively natively multimodal, and multimodal is, well, it works well along with the 12 Labs APIs. So, well, yeah, it integrates together pretty well. And also, I believe on benchmarks, Gemini does quite well on reasoning over structured data and so things like long context windows. So, yeah, that's also the other reason why we did this. And I guess one possible concern is hallucination, since on benchmarks, Gemini seems to have higher hallucination than things such as Claude, maybe. But for us, that's not really the issue, since when trying to suggest new products, you're trying to suggest a creative product. So that's what we are prioritizing here. And then because it's human in the loop, after that, the human can see, well, is this just a hallucination or is it actually something valid? And based on our testing, it's usually pretty valid.
So, I saw the choice of both MongoDB and GraphQL in this pipeline. Can you talk more on the database design and why Mongo and GraphQL?
so was the question why we use MongoDB? And so for MongoDB, it's mostly unstructured data. Like the trends could have various different types of data forms that we want. And for a structured database, it's a lot more adaptive for what like each video could have something more the different metadata tag or different variable that we want to store based on that the Gemini agent could use to better suggest products. And for GraphQL, that's what the Shopify's current like native API is for us to use in order to make any sort of changes to the admin page or even just stores in general. So that's why we use that.
Makes sense. At the ingestion layer, I believe you use YouTube API to extract video, right, of the product, and then fed that into Basis so that it can get the trends and analysis from this video. And any feedback on the quality of a Basis, like does it perform well? What are the strength and limitation of the output based on your experimentation?
I have some comments. So like it can analyze like movements and some gestures really well. Like I was impressed. But one thing I noticed was it lacks like recognizing specific images or textures and describing them. So while we were like analyzing YouTube Shorts, like I feel like it's sometimes missed logos or like some specific images of the trends we were trying to identify. So but other than that, it was really good at identifying like the mood, the aesthetics, the movement. But I feel like it should be able to identify more specific image context.
When you say like specific image, you mean like logo, brand name, like a brand, right?
Like it sometimes doesn't recognize like the specific trends or the meme we were trying to analyze. So like for example, in the chill guy example, there were some videos where chill guy was like on a t-shirt or on a phone, and the AI didn't really recognize it, I feel. Yeah.
So okay, so like an action, specific action that correlate and being shown in the video.
Yeah, you could.
Got it. Yeah, that's definitely great feedback. We have a new version of Pegasus coming up soon. That is very like that is designed for like time-based metadata, meaning that you can specify, you know, time-based as an input in the parameters of the analyze API, so that you can, I don't know, like get very specific segments out of the video if your use case is about like extracting, you know, moments and activities. Yeah. And I think like based on the early testing of that version of Pegasus, it did perform better than this current version. So, you know, definitely take into account this feedback from the developer community to make the you know, make the performance of the model become better for these use cases. All right, I think that's all the question that that folks have for the second group. So thanks again, Attila, Andrew, and Lukhsaan for presenting TrendID. Very interesting project that speak to kind of the advertising e-commerce use cases of Toll apps, and you know, in this specific like vertical, I think, you know, the ability to do product recognition, you know, detecting like trends and relevancy, I think is very important, and we will always, you know, try to make our model better for this new type of data. So yeah, thanks again for being with 12 apps for this specific application, and hope you have fun, you know, trying our API. So this is the end of the session. Thanks everyone for joining. The recording will be up on YouTube probably at some point early next week. And yeah, if you found this content informative and exciting, we run this session on a weekly basis every Friday. So yeah, stay tuned, and you know, hope to see you next time. Cheers everyone, and enjoy the rest of your Friday. Bye.